additive inverses. So when we add A to the opposite of A, they are additive inverses because the answer is 0. So what am I saying here? On the real line or the number line, two numbers that have the same distance from 0 but are opposites, left and right of 0, like for example, -3 and +3, are additive inverses. Because if I add 3 to -3 or I add -3 to 3, I get 0. Now, what happens when I'm asking, for example, I'm asked, let's say x equals 27. How do I determine the opposite of x? Well, the opposite of x would be -27. So later on, we're going to get to equations, and we are going to multiply both sides by -1, and this is what we get. Multiplying both sides by -1 in an equation is allowed. It does not change the equation, or it changes the outlook of the equation, but not the final solution. That will always be the same. Okay, I would like to, 1 second, to find again the practice for 1.1. I'm going to share my screen. Is anyone waiting in the no. Okay. For some reason, I thought there was somebody waiting, and I forgot to click. Okay, so we stopped at 13. I saw that many of you already completed this assignment, which is fine. Is there a particular problem that you would like us to look at, to practice with? You should always write down any problem that you would like to start with or would like to work on in class. So we analyze this situation. Let's analyze it again. Can anyone give us an idea of what does this mean? And what will you do first?
The negative value, the absolute value of -4.
Okay, first of all, the absolute value of -4, which is?
4.
Okay, and then the final answer would be?
Times -1.
Exactly. That's exactly it. So we did this problem together. We determined the absolute value of -4. We did get 4 because that's what it is, the distance, the number of units between -4 and 0, and then we multiply by -1, so the answer is -4. You always stop me if you have questions, please. Okay, now this is a totally different story. Why 14 is different than 15? Because this is not a grouping symbol. But 15 is a different situation. So so again, please understand, these are two different situations. I put -14, it doesn't matter, okay? So this not being a grouping symbol, this has to be analyzed or determined or simplified first, which is 14. -1 times 14, because they are two numbers with opposite signs, the answer is -14. This is a different story because this is a grouping symbol. And I will multiply -1. There is an invisible -1 in front. I will multiply two negative numbers, so therefore the answer is 15. See the difference between these two? Why? Because this is not a grouping symbol, and it cannot be treated like one. Okay, so I see some questions here from Bobby. I have a question regarding something else. Okay. Yes, we discussed this extensively last week, and we said that the assignments are due when we finish them in class. So assuming that we finish 1.1 everything learn and practice, 1.2 everything learn and practice, let's say 1.3 today, these assignments are due on Thursday before class. We do not go by the due dates in Pearson. Those mean nothing to us. Those are just the dates until the assignments are still open for you to review, to look at, but not necessarily to work on. Is this clear now, Bobby? Good. Perfect. Very good. So let's go on. Okay. Good. Now, I think that this is understood, but does anyone want to choose any of these? Do we need to work on any of these problems? Please look at them and say yes or no. If you say no, it means it's okay, we move on. If you say yes, please choose. Nobody said anything? Okay, then, perfect. It means that everything is clear here. Okay, order the given numbers from least to greatest. Are we okay with this problem? Are we okay with analyzing and simplifying each and every one of them and then put them in the correct order from the smallest to the largest? I heard nothing, so I will move on. You can always stop me, please. Okay, so write a computation to represent the situation and interpret your answer. So I owe you $16 and I ask for 32 more. So I owe you 16 and I said I don't have the money yet, but I really, really need another $32. How much do I owe you right now? You're kind enough to give me 32. You gave me 16 and now you're giving me 32. How much money do I owe you now?
48.
Yes, and that has to be with negative. So negative 16, I'm in minus. I'm in minus with 32. So now I'm in minus with $48. Agreed, everyone? If I don't hear anything, I move on.
Yes.
Okay, perfect. Let me know. Okay, so the same idea, but she has a debt. So I owe you $19,600, but I received somehow $25,000. How much will I still have left after I pay you the $19,600? Which
D400.
okay, so which part will I be choosing from A, B, C, D?
You're going to choose C.
I will not choose C.
No, you're not going to choose C. I'm sorry. You're going to choose D.
Exactly, I will be choosing D. Good. Thank you, Nadi. Good. So now I want to talk about rules of addition. That's where we are right now. Adding numbers. So there are several properties of adding numbers. Here's one. If we add two numbers, A plus B, it's the same with adding them in any order. So for those of you who are already ahead, you probably got to order of operations. We're going to talk about them extensively. But I disagree, and I think it's incorrect what they said in there. So they said this, that the addition of two numbers or more has to be done in order from left to right, and that is incorrect. Addition of numbers can be done in any order, from left to right or from right to left. A plus B is the same with B plus A. And this is the commutative rule. Commutative law or commutative rule. Here's another one. A plus B grouped, grouping symbol, plus C is the same with A plus B plus C. So what happens here, I grouped them differently. So first, because I cannot add three numbers instantaneously. So I will be adding two numbers. When I'm done, I will be adding the third one. But it doesn't matter if I start with the first two or if I start with the last two and then add the third. So the first two plus the third, or the last two plus the first. The answer will be the same. And this is the associative law. The associative law or rule. Okay. Now, although this is not a specific situation for addition, I'd like to add it here. So if I have a negative symbol or a negative sign or an imaginary -1 in front of, let's say, a plus b, I will be using something that is called the distributive law. So it doesn't really belong at adding numbers because basically it's a combination of multiplication and addition. So when we combine these, it's no longer an adding property, right? So this is a distributive law. So what does this mean? It means that I have to distribute -1 to a, so -1 times a will be -a, and I distribute -1 to b, and this will be -b. I didn't want to wait till we talk about the rules or the properties for multiplication, because we have already seen this before, and I just wanted to put it in ahead of anything. Okay, now 0 plus a plus 0 or 0 plus a is the same thing. So when we add 0 to any number, we get the number back. And of course, here is another property that we just discussed. A minus a is 0. Or reverse. When I reverse, I have to take the symbol. The symbol belongs to this. You cannot leave the symbol behind. So I will put -a in front. And since there is no symbol here, it's an invisible plus. We all have to know that. So when I say 3, I mean +3. Otherwise, I would say -3. So -a plus a, they're both 0. +a minus a or -a plus a. Okay. Now, since I already mentioned what happens with this invisible sign or number in front, so to speak, well, always remember when we write 3a, we really mean multiplication. Otherwise, it would have been addition, subtraction, or division. So this is the only symbol that most of the time we don't write. Now, if I want to multiply 3 by 39, I cannot write this. This will not tell you that this is 3 times 39. So I have no choice, but I have to present the multiplication symbol. But otherwise, 3a means 3 times a, but the symbol doesn't have to be presented or written. Okay, one other thing that I want to mention here is, you've seen this already and we will see it again. Let's say 2a divided by 3. This is very important to understand that whenever you see something like this, you also have to picture immediately something like, which is equal to 2/3 a, not 2/3a. So see, 2 and a are in the numerator, 3 is alone in the denominator. What does this mean? Well, this means basically a/1. But this is a totally different story. I've seen this mistake in papers, in students' exams. So please remember, if a is in the numerator, it cannot be considered to be in the denominator. So this is the same thing. And this is a very important situation for later. Okay, moving on. Now, whenever we have positive in front of a grouping symbol, like this example, this is a situation that complicates things. Why does it complicate things? It's because this is a grouping symbol. We normally use grouping symbols for operations. This is the main use of grouping symbols. But here, I do not have any operations to perform. -2 is just a number. So this is not a grouping symbol. This is just a way of separating two operation symbols. We're not allowed to have two operation symbols sitting next to each other. I can never write positive -2. This is incorrect. So I want you to understand that this particular way of writing it, although it's a grouping symbol, it's called parentheses, the grouping symbol here is not indicating that we have to perform operations inside. No, it separates two operation symbols. The first step, and you're going to see me do this a lot, jump over this and look for the triangle. So this should not be calculated in this way. Should be rewritten as 4 minus 2. How come? Well, there is still a +1 hidden in here. But when I multiply a positive number by a negative number, I get a negative number. This has to be the next step. And now you can write 2. You can say, oh, but what if I write 4 on the number line and then I'm adding -2, so I'm going back 2 units? Yes, that's perfect. So I start with 4, and I have to go backwards 2. So the answer is here, which is 2. Correct. But really, there is no need to go to this extent. As long as you understand there is an imaginary 1, +1 times -2 is -2, and at this point it's very simple to calculate 4 minus 2, which is 2. So this is very important to understand. So sometimes we use grouping symbols, but normally grouping symbols are hiding operations inside. I have to perform something to eliminate parentheses, but not in this case. In this case, the grouping symbol is used to separate two operation symbols. That's the reason why I wanted to discuss all these things, because there are many different ins and outs of these problems that I want you to understand. Any questions here, or we move on?
I do have a question.
Yes, please.
The distributive property, going back to the distributive property.
Yes, yes.
The absolute, what is it? What happens with absolute values?
Very good. Can you give me an example? Excellent, Glenn. I really appreciate it. Thank you.
Would they behave the same way as grouping symbols?
No, 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 because they're not grouping symbols. Would you have an example for us? Very good question. I always tell to all my groups of students, and I really mean it. You know me already. I'm not a sophisticated person. I will never tell you I like you and I know in my head. No, I don't. So your questions make me a better professor. Okay? Any question? Any question? I wish I had another camera so you can see me, but every time I try that, there was some sort of interference and nobody could hear me. So I'm not hiding. Okay, so do you want me to make up an example or? Okay, so if I have, let's say, negative the absolute value of 2 minus 3, I have to perform the operations here because this is not a grouping symbol. So I get -1. Now I'm still forced to find the absolute value of -1, which is 1. And only then I multiply by the invisible -1, so I get -1 in front. I'm not allowed to do this. No, because the absolute value is not a grouping symbol. I'm allowed to do it here because parentheses are grouping symbols.
Okay.
Could you please do one more example of that?
Of this one?
Yes, please.
Yes. Would you like to choose one or? Okay, I'm gonna, this time I'm gonna choose something a little bit more sophisticated, let's say. So 3 minus 4 multiplied by 2 plus the absolute value of -1 minus 3. Okay, so I'm jumping ahead a little bit. We're going to have more examples, of course, but since we had a request for another example, let's do this. First, I look at the first absolute value, and I think, what operation do I have to perform first? What do I see? I see a product, and I see a subtraction. Nothing else matters. You will see I have a lot of props here ready to go. So that's all I see. So when I multiply 4 by 2, or if you want -4 by 2, however, I prefer 4 times 2 is 8 with minus in front. So it's going to be -8. So now I copy the negative in front, and I copy 3 minus 8. I copy the positive symbol. At this point, I don't see anything else but this. I owe you $1, and then I beg for 3 more. So obviously now I owe you 4. So far, so good? Now, I go back to the beginning. I copy the negative sign. I perform the operations inside. This is not a grouping symbol, but I have to perform the operations I see. 3 minus 8. I have the absolute value of -5. Now plus, I copy the plus. Now I know that the absolute value of -4 is 4, and I copy it. I go back. The absolute value of -5 I know is 5 with a minus in front, so this would be -5 plus 4. I owe you $5, but I have 4 to give you back. Since I owe you 5, but I'm giving you back 4, I am down to -1. So I still owe you $1. So this was a little bit more advanced, although we did not talk about the order of operations yet. But I just wanted to show you how we think when it comes to more sophisticated or longer operations. Sarah, is this okay? Good.
That's perfect. Thank you so much.
I waited for you last night. You didn't show up. I wasn't sure whether